and welcome back for Chapter 3, Lesson 6. Today we're going to be discussing the arithmetic sequence. So our objectives for today are to recognize and extend the arithmetic sequence, and then also to find a given term of the arithmetic sequence. Okay, let's go ahead and get started. So, during a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning until you hear the thunder. Have you guys ever done that before? It's kind of fun. Except if the lightning's like super close, then it can kind of get a little scary, but yeah. Okay, when you list the times and distances in order, each list forms a sequence. A sequence is a list of numbers that often forms a pattern. Each number in a sequence is a term. All right, so let's go ahead and look at this particular example here. So this is talking about the number of lightning strikes and the times and the distances, how far the lightning bolt is away. Now, I always thought, what I heard was that if it was 1 second away, that every second meant a mile. But in this example, it doesn't seem like that. What it looks like is if it's 1 second away, it's 0.2 miles away. I didn't know that. Or maybe this, so yeah. So if you look at from here to here, from 0.2 to 0.4, we're adding 0.2. If you look from 0.4 to 0.6, we're adding 0.2 again. And from 3 to 4 seconds, or from the distance of 0.6 to 0.8, we're adding another 0.2. And it just looks like we're adding the same amount of distance for every second, right? So let's see what happens from 0.8, from 4 seconds to 5 seconds. Well, it's another plus 0.2, and so on, and so on. Okay? So you can see that it has this consistent increase of 0.2 of a mile. So in the distance sequence, each distance is 0.2 of a mile greater than the previous distance, and we see that. When the terms of a sequence differ by the same non-zero number d, so d is the difference, right? The sequence is an arithmetic sequence, okay? So notice how it's the same difference every single time. This is an example of an arithmetic sequence, and d is the common difference. So what is the common difference? Well, the distance in the table from the arithmetic sequence is d equals 0.2. All right? So the variable a is often used to represent terms in a sequence. The variable a with this little itty-bitty 9 that's kind of lower down, we read that as a sub 9. So this is a sub 9. And that's the 9th term in a sequence. Okay, so when you have a term, when you have a sequence of numbers, which is like a list of numbers, you could have a, and then you could have a, and then a, and then a. But how do you tell them apart? Well, that's why they use these little sub numbers. So a sub 1, that's the first term. A sub 2 is the second term. A sub 3 is the third term. A sub 4 is the fourth term. A sub 5 is the fifth term. A sub 6 is the sixth term. A sub 7 is the seventh term. A sub 8 is the 8th term. And lastly, A sub 9 is the 9th term. So that's how A sub 9, that's what that means. So there's all these 8 terms before A sub 9. So it's the 9th term in the sequence. To designate any term or the nth term, so if we want to keep going and keep going on and on and on forever, these 3 dots mean on and on forever, we would get to the nth term. Okay, and a sub n, which is the nth term, okay, where n can represent any number. To find a term in arithmetic sequence, add d, and remember that's the common difference, to the previous term. So this is actually finding a term of an arithmetic sequence. This says the nth term of arithmetic sequence with common difference d is found by, so you can find any term by taking, so that's a sub n, that means any term, and this a sub n minus 1, that looks complicated, but let's just think about that for a second. What is that? So let's say we have this formula, okay, the nth term equals a sub n minus 1 plus d, right? Let's say n equals 5, right? So we substitute 5 in. What does that mean? Well, that means now we're trying to figure out what the fifth term is in the sequence. So then we substitute 5 in here for n as well. And then what is 5 minus 4? Well, 5 minus 4, well, I'm sorry, 5 minus 1 is 4. A sub 4. So look at that. This n minus 1, that just means the term before the nth term. You see, we have, if you want to figure out the fifth term, you take the term before it, which is the fourth term, right? And that really works for anyone. Let's talk about the eighth term. Well, if we go 8 minus 1, what do we end up with? We end up with the seventh term, right? Which is the term before it. How about we take the a sub 4? What happens if we went 4 minus 1? Well, we'd end up with 3, which would be the term before it. So when you see this nth term like this, and then you see this n minus 1, that minus 1 just means whatever number that is, you minus 1 to it, and you're going to end up with the term before this term, okay? So all this is saying is if you want to find a term in an arithmetic sequence, you take the term before it and add the common difference to it, and you'll get that term. All right, so let's start and look at some examples, okay? So, example 1a. All right, so determine whether the sequence appears to be arithmetic sequence. If so, find the common difference in the next 3 terms. Perfect, okay. So we're just gonna see what's going on here. So from 9 to 13, what is happening? Well, it looks like it's 9 plus 4 is 13, right? What about 13 to 17? Well, yeah, we just add 4 again. What about 17 to 21? Well, yes, we add 4 again. Well, perfect. Okay, so this looks like it's yes, this is an arithmetic sequence. Yes, an arithmetic sequence. Okay, so if it's an arithmetic sequence, then we have to find the next 3 terms, okay? So, right, this is our first term, our a sub 1. This is our second term. This is our third term. This is our fourth term. So we want to find the fifth term, right? So we're just going to take our formula. A sub n equals a sub n minus 1 plus d. Okay, so we need to determine the fifth term, right? So that means we need to figure out what n equals 5 is, okay? When you put 5 in there, that's the fifth term. We need to know what the common difference is. Well, the common difference is 4, right? And then we just substitute these values in. So n goes in, 5 goes in for n equals 5 minus 1 plus the common difference, which is 4. 5 minus 1 is 4, so a sub 4 plus 4. And then we just need to figure out, well, what's a sub 4? It's 21. So we substitute 21 in here for a sub 4. And then we get the next term, which would be 25. Okay? So that is the way that you would do it with the finding a term in the arithmetic sequence. So that's only one term. right? But with something like this, I'm totally okay with you just saying, oh, plus 4, plus 4, plus 4. Okay, 21 plus 4 is 25, and then 25 plus 4 would be 29, and then 29 plus 4 would be 33. So those would be the next 3 terms. I'm okay with that, but I just wanted to give you an example of how this formula relates to this. So this is how we'd find the 25th term, and then we'd have to do this whole process again to find the 6th term and then the 7th term, because this is the 5th, this is the 6th, this is the 7th term. Okay? But I just wanted to show how that formula plays in since we were just talking about it. Okay, let's look at the next one, 1b. It says determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference in the next 3 terms. Okay, so let's look here. What's happening? From 10 to 8, it looks like it's getting smaller, so it's being subtracted by 2. What about 8 to 5? Well, it's getting smaller again, but now it's subtracted by 3. And then lastly, from 5 to 1, it's getting smaller and it's subtracted by 4. So since these are not the same, this is not an arithmetic sequence. And that's it. All right, let's look at another example here. Ooh, fun, fractions. Okay, so what is happening here? So we have -3/4, and then -3/4 is turning to -1/4. So what is happening? 3/4 is smaller, and this is getting bigger. I almost want to say that we're adding 2/4, right? -3 plus 2 is a -1/4. Okay, what about here? Let's see if that happens. -1/4. If you add 2/4 to it, -1 plus 2 would give us a +1/4. So yeah, that would be 2/4. And then let's look here from 1/4 to 3/4. If you went 1 plus 2, that would give you 3. So yes, it's 2/4 again. And we know that 2/4 can be reduced to 1/2, but I think we want to just keep it as in 2/4 so it makes it easier to add. So this is, we have to find the next 3 terms, right? So we're going to say, yes, this is arithmetic sequence. Woohoo! That one was a little tricky with the fractions. But it's nice they have the same common denominator. So it was almost like if you could just look at it like this. You know, plus 2, -1 plus 2, 1 plus 2 is 3. So -3 plus 2 is -1, -1 plus 2 is 1, 1 plus 2 is 3. But, I mean, and then make it force. If they all have the common denominator, then you could kind of think about it like that. Okay, but anyway, so we need to come up with the next one. So the next one would be 3 plus 2, which would be 5/4. And then we would add 2 to that, which would be 7/4. And then we'd add 2 to that, which would make it 9/4. So those would be the next 3 terms. Perfect. Okay, let's look at the next example here. What is happening in this problem? Okay, so we have -4 to -2. -4 to -2. Okay, it's getting bigger. How much is it getting bigger by? Think about it. -4, I would say plus 2 is -2. Okay. What about from -2 to +1? Well, that would be a difference of -2 plus 3 would give you 1. And then here from 1 to 5, that would be 4. So we don't have a common difference, so this is not an arithmetic sequence. All right, that's it for this example. I'll see you in a little bit for example 2.